Managing table spaces. And this nugget will take a look at what a table space is used for and what exactly is in it. Remember, a table space is the largest logical unit in the database. I'll also show you how to assign table space quotas to users to either disallow object creation in those particular table spaces or to set a quota or make it unlimited. Every table space is either going to be locally or dictionary managed. We consider dictionary managed to be the old style, and we'll talk about the differences between the two. For backwards compatibility, we still have dictionary managed. In 10G, we have a new type of table space called a big file table space, and that's going to be really useful in an environment where you've got huge amounts of data, like terabytes or petabytes of information. You can also make your table spaces read-only, and then we'll cover the differences between regular, undue, and temporary table spaces, and I'll show you examples of all of these. Also new to 10G, we have what we call temporary table space groups. That's going to be really useful if you've got users who have really intensive sorting operations, and you want to give them a lot of power to sort their information on disk in case there's not enough memory. And then I'll show you the exact syntax for creating, renaming, and dropping table spaces, as well as looking at your information in the data dictionary view. For example, you can see what segments are in which table spaces, you can see which data files make up the table spaces, and so on. Let's talk about what's in your table spaces. Remember that the largest logical unit of your database is your table space. Well, what do I mean by logical? I mean that when you're on the operating system level, you can't see what your table spaces are. But when you're querying the data dictionary, you can. Now, when we talk about data files, that's an operating system unit. So your table space can contain 0 or more segments. There's all types of segments. For example, we've got table segments, index segments. And if you create a new table or an index or some other type of database object, then it has to go in some table space, and a new segment is going to be created for it. Now, your segments are made up of extents. An extent is just a contiguous chunk of database blocks, and a database block is the smallest logical unit in your database. Now, I've drawn out here a very minimal configuration for a database. I've provided 5 table spaces. I have stars next to system and sysaux because those are absolutely required in Oracle 10G. In previous versions of Oracle, only the system is required. So in 10G, the system table space is supposed to be used solely for data dictionary objects. The sysaux table space is supposed to be used for miscellaneous features of your 10G database. Now in Oracle 9i and earlier, they just combined all the information in these two table spaces and put it into system. You also need to have a temporary table space. That's going to be used for sorting on disk in case we run out of memory for sorting. And you're also going to have an undue table space to hold the before image of any changed data. So that's going to be used, remember, for rolling back transactions, flashback query, read consistency, and so on. Now this last table space I have here, I just called it users. Really, you can call it anything you want. This just contains data for the users. So you might have hundreds of table spaces like this where you can logically organize your application data. Now when we get to our performance tuning nugget, I'll show you the most optimal way to lay out your table spaces so you have the best performance. In order for someone to create an object in a table space, they had to have been granted the quota on that table space. Now by default, a user doesn't have a quota on any table space. So you can either specify a number or you can say quota is unlimited. There's also a role called unlimited table space, which gives unlimited access to all the table spaces for a particular user. That can be kind of dangerous though, but you will see that in the real world. There's a data dictionary view called DBA TS quotas that shows us what the quotas are on all the different table spaces. So I'm querying Scott here and shows that the max bytes is -1, which means unlimited. So Scott has unlimited access to this table space and cannot write any objects to any other table spaces. Now, Scott can write to objects that maybe belong to someone else in other table spaces, and that's fine as long as he has the associated privileges. So just keep in mind that this table space quota has to do with the objects that he owns. Now on my database, I have another table space called example, and what I'm doing here is I'm granting Scott a 5 megabyte quota on that table space. So my user was altered, and we run this query again, and you'll see that it is 5 megabytes. Take this number, divide by 1024, and then by 1024 again, and it will come back as 5. Now let's assume that Scott has created a bunch of objects in the example table space, and then I go back as a sysdba and say that his quota is now 0. It's not going to affect the objects that are already in there, but it will affect any types of objects that he tries to create later. Now here I'm just showing you how you can grant the unlimited tablespace privilege to Scott. And you may query the data dictionary view called DBA sysprivs to see which privileges Scott has. So unlimited tablespace is there. Let's talk about locally managed versus dictionary managed table spaces. Now, locally managed table spaces have been available to us since Oracle 8i, and dictionary managed is still around just for backwards compatibility. Now, your database has to keep track of the status of your database blocks. For example, whether it's free to be used, whether it's empty, whether it contains data, whether there's a lock on it. Well, with locally managed table spaces, all this information is tracked in a bitmap on the data file level, whereas with dictionary managed table spaces, all that information is stored in the data dictionary. Well, the problem with that is that your information in the data dictionary is stored in the system table space, and resources that are trying to access that information are competing to access your data dictionary. And so there's a lot of locking going on for the data dictionary. So the bottom line, locally managed table spaces are a lot more efficient. Another advantage is that locally managed table spaces allow for uniform extent management. For example, you can specify when you create your table space that each extent that's going to be created is going to have the same size. Whereas with dictionary managed, you don't have that power. Now, what's the advantage of that? Well, uniform extent management allows the database to avoid fragmentation. Fragmentation is just when you have gaps in your extents. Bottom line is when your database is fragmented, you've got a lot of wasted space. Now, another advantage of our locally managed table spaces is that they do not generate any undue information. Remember, everything's maintained in the data file headers. The bottom line here is that locally managed is good, dictionary is bad, and it's only there for backwards compatibility. So if you do have some dictionary managed and you want to convert them over to locally managed, you can do that. The way you would do that is through a package that's provided for us, and you would convert all of your non-system table spaces to locally, and then the last thing you do is change your system table space to be locally managed. The only caveat here is that temporary table spaces are not allowed to be migrated. So my statement down here in green, exec dbms space admin dot tablespace migrate to local, you pass in the tablespace name, and that does the migration for you. Oracle 10G introduced a new type of tablespace called a big file tablespace. A big file tablespace is one that contains only one data file, but it can be really, really large, up to 4 gigabytes of blocks. So if you've got a 32K block size, you can imagine how large that is. This is going to be really helpful in an environment where you've got huge amounts of data, like petabytes or terabytes of data, and you don't want to separate out all your stuff into smaller files. You can make your table spaces read-only, not only to protect your data, but also to save space during backups. For example, you might just back up your read-only table spaces once, and then every night when you do your database backups, you can skip over the read-only ones because they're already backed up and they're not changing. So to modify a table space to be read-only, you simply say alter table space, then the table space name, read-only. And to make it writable again, you just say that it's read-write. Now be real careful when you're trying to make it read-only. You can't have any activity, any transactions going on on that table space when you do that. Otherwise, you'll just end up hanging there waiting for the user to commit. Temporary table spaces are used for performing sorts on disk. Now, when you're performing some kind of query that involves a lot of ordering, or if you've got joins, most likely there's going to be a lot of sorting going on. And that's supposed to take place in memory, in your SGA. But if you run out of memory there, then of course it has to occur on disk. So which is more optimal, having a sort in memory or on disk? Well, optimally, we'd love to have everything happen in memory, but that's not always going to be the case. It's considered a good practice to set up a default temporary table space for the whole database, and then you can change that per user if you'd like. Temporary table space groups, which is new to 10G, is a way that you can harness the power of more than one table space for a sorting operation. So if you've got a user who's got a really intensive query, then you might want to add some table spaces to a table space group and then make that group that user's default table space. So to see what your temporary table spaces are, just query DBA table spaces view where contents equals temporary and make sure that's in all uppercase. So I have one temporary table space. Let's create another one. And to create my temporary table space, I say create temporary table space and then the table space name. Make sure you say temp file. And then the full path of where you want the data file or files, and then the size. So if you want to change the default temporary table space on the database level, just say alter database, default temporary table space, and then the table space name. And we query our database properties, where property name equals default temp table space to find out what it's currently set to. Here it's temp2. And you can override that behavior for an individual user. So here I'm making Scott's default temporary table space be temp. And you can query the DBA users view to see what that individual user's temp table space is. And if you want to find out what files go with which table space, query your DBA temp files. Note that this is different from DBA data files, which is used for regular table space files. Okay, so there are my files. Now, if you want to harness the power of more than one table space at the same time, 10G offers temporary table space groups. And we implicitly create those groups just by specifying that a table space belongs to the group. For example, here, alter table space temp, and then we say table space group, and this is the first time that we're even creating this group. We're implicitly creating it. We'll call it TBS group 1. And then our next statement is adding our temp2 table space to that group as well. So now if I want to have Scott utilize the powers of both of these table spaces at once, I can alter that user and make that the default table space. So here I'm altering the user, and his temporary table space group is now TBS group 1. If you want to remove a temporary table space from a group, just alter that table space and specify that the table space group is a null string, just like I did here, just an empty single quote. And to find out whether or not you have temporary table space groups and which table spaces belong to them, simply query the DBA table space groups view. And there we go. Remember, we removed temp2 from that just a moment ago. And there really is no limit to how many temporary table spaces you can have in a group. And to make your database's default table space that group, simply say alter database, default temporary table space, and the group name. I'm going to show you some more examples on creating table spaces and all the various options associated with them. Now what I've got here on this board is some of the more common attributes that you can attach to a table space. Anything in square brackets is optional, and anything underlined means it's the default value. So when you're creating a table space, you can specify whether it's a big file table space or small file is actually the default. Remember, if you're creating a big file table space, you're only allowed to have one data file in there. So it's a good idea to make this file auto-extensible so it can grow and grow and grow. The other option is you can specify a really large size at first, and that's just going to be the cap on the size. The problem with that is when you create that initial big file, it might take a really long time for it to create the file. You have the options for undo or temporary for your table space. If you leave off either of these options, then it's going to be a regular table space. If you're creating either a regular table space or an undo table space, then you'll have the data file clause. Remember, if you're using a temporary table space, instead of saying data file, you'll say temp file. So your file specification is going to be the full path of your data file, the size of that data file, and you can also say reuse in case it already exists on the OS level. And you can also say auto extend on, which means that that data file can grow and grow and grow. Okay, so here we have a quick little example here. The default behavior is to have the auto extensibility off. You can also say how large your block size is going to be for that table space. If you don't say how large it's going to be, then it will default to whatever the default is to the database itself. So on my system, it's 8K. Be aware that if you make a table space any other size besides the default, that you're going to have to set up a caching area for that database block size. And I'll show you in a moment how to do that. You can also say whether or not you want logging going on. Now this has to do with the redo logs. By default, redo logs are going to be generated for your table spaces. If you specify no logging, then no redo is generated and you're not able to recover. Now why would you want to do that? Well, if you're on a development system and it's really not really important data, you want to free up some of the processes, you don't want to have the log writer doing a lot of activity, this might be a scenario. You can also specify the compress option. Table space compression is going to help the performance of your queries usually, and it's typically used in a data warehousing environment where you have just a relatively small amount of tables, but they're really large. And what compression does is it eliminates any repeating values in certain columns. And there's an internal algorithm provided by Oracle that determines how to compress. You have an optional storage clause that you put in parentheses. So here in blue, I have some of the options for the storage clause. If we say min extents and then some number, that's telling Oracle the smallest amount of extents we can have in that table space. So when we initially create the database, if we say min extents 3, then it will initially create 3 extents. You're essentially pre-allocating space to improve performance if you have tables that you want to quickly load in your table space. Now max extents is also a number you can specify, and that's just giving a maximum number of extents to put a cap on your extents in the table space. You can also tell Oracle where you want the database blocks to go from this table space when you're running queries. By default, those blocks are going to go in the database buffer cache. You can also set up two other caches. One is the keep cache and the other is the recycle. The keep cache is typically going to be used for lookup tables. So if you want to keep those pegged in memory, you can do that. Now the recycle area is used typically for pieces of information that you don't want to have going in either of these two caches. It's just a way to prevent certain database blocks from clogging up the cache cycle. Think of this as being the throwaway bin. We have an extent management clause. Now you can say extent management dictionary. I didn't even put that in there because remember, dictionary managed table spaces are considered a really bad idea nowadays. It's just there for backwards compatibility. But you can say extent management local, which is the default behavior, and another clause that goes with that. You can either say auto allocate, which is the default behavior. This just means that you want the Oracle system to allocate extents according to its own internal algorithm. Or if you want to specify how you want the extents to be managed, you can say uniform and then give a size. Now if you leave off the size, then uniform defaults to 1 megabyte. In other words, if you say extent management local uniform size 10 megs, then every new extent is going to be 10 megabytes large. If you say extent management local uniform, then each new extent is going to be 1 megabyte large. If you say extent management local auto allocate, then you don't know how large those extents are going to be. It will be automatically determined by Oracle. You can also specify the segment space management clause. You have two options. You can say auto or manual. Auto is the default, and that's actually Oracle's recommendation. You're just letting, once again, the Oracle system determine how to manage your extents. Or you can say manual, and then when you create your individual database objects, you can be really clear on how you want those segments managed. Now we'll talk in a later nugget about manual segment space management. Let's look at the table spaces we have and the associated data files with them. So I'm querying from DBA data files and doing a union, which is essentially just adding the results together. So taking these results here and these results on lines 4 and 5. DBA temp files gives us information about our temp table spaces. And you'll see that all my table spaces here contain one data file except for the users, which has two data files. Now we're going to create yet another table space. Let's call it users2, and we want to have this have two data files. And I'll show you the bare bones syntax that you need to create this regular table space. So create table space, the table space name, then the keyword data file, and then we'll have a comma-separated list of our data files. Make sure it's in single quotes. If you're on Windows, it's not case-sensitive. If you're on Unix or Linux, it is. Then you can say size, and reuse is optional. Like I said, if you want to make it auto-extensible, you would say auto-extend on. And our table space is created. Now keep in mind that if your table space sizes, if these data file sizes are large, then it might take several minutes for this table space to create, because on the operating system level, it has to allocate that space. It's not uncommon to create a really large table space and sit there twiddling your thumbs for 20 minutes waiting for the creation of it. Now let's create a big file table space. We'll call this big_ts. And remember, this can only contain one data file, and that data file can get really large, up to 4 gigabytes of database blocks, whatever your block size is. So if my database block size is 8K, well 8K times 4 gigs, that's a pretty large amount of data. And we go ahead and create this. So see how I said auto extend all. This 10 megs just means that the initial size will be 10 megabytes, and then the data file can grow according to the database's needs. I'm going to now show you how to create a table space that is a non-default block size. So when we say show parameter DB block size, here it tells us that our database block size is 8K. You can have other table spaces with some other block size, but before you create it, you need to make sure that that block size has a special cache allocated to it. For example, if we create a table space with a 16K block size, we need to make sure that we have a 16K block size cache allocated. Why would you want to have a block size that's not the default size anyway? Well, let's say you're in a data warehousing environment and you've got a table that has really long rows. Well, it might make more sense to optimize your space usage and have larger block sizes. So here I'm altering my system and I'm setting the DB 16K cache size to be 10 megabytes. So any table space or any database object that is of 16K block size, well, instead of going into the default database block cache, it's going to go into this special cache. So now we create our table space. We'll call it big block TS. We've got our data file. That's going to be 5 megabytes. We'll use the reuse clause. We can turn auto extensibility on if we want, and here's where we specify the block size. You might want to set up a table space with a small database block size if your row lengths are really small. So here, once again, we make sure that we have a cache size available for that. So here we're making a cache size for our 2K database blocks, and then we create our database. See how I specify block size 2K down there? And we'll talk more about how to determine what the block size should be in our performance nugget. You can make your table space eliminate any redo information by specifying the no logging clause like I did here. Turning on the no logging option is going to improve your performance typically because you don't have the log writer process running in the background on this table space. This next example is just showing you how you can specify a min extents of some number other than 1. So when we create this lookup table space, there will be automatically 5 extents from the get-go. And why would we do this? Well, if we want to pre-allocate some space to do some bulk loading of tables in there. Okay, so our table space is created, and now we can create a table that belongs to that particular table space. So that sums up most of the options to creating a table space. Let's talk about renaming them. Now, Oracle 10G offers a new feature, and that's renaming a table space. Prior to 10G, if you wanted to rename a table space, it was a really long process. What you really had to do was export all the data to a new table space, drop the original table space, and then create it, and then load it back in again. It took a really long time. So this is a really neat feature. You just say alter table space, then the original table space name, rename to, and give it the new name. Dropping a table space is really easy too. You just say drop table space, give it the name, and an optional clause, including contents and data files. Now, if you leave that clause off and your table space contains any objects, then you'll get an error. By specifying this clause, it's going to drop all the objects in there, and it's also going to remove the data files on the operating system level. Okay, so we just drop the table space. How about renaming data files? To rename a data file, you need to either have the database in mount mode, which involves some downtime for all the users, or the more optimal choice is to just take the table space offline, do the modification, and then bring it back online again. So I'll show you how that's done. How about changing the data file for our user's table space to include an underscore in front of the 01 and 02? So we alter the table space, users, offline. You can then go to the OS level and rename the data file. Well, I'm on Windows, and I'll just do it through my GUI interface here. And then you need to update that information in the data dictionary, and we do this through the alter database statement. So alter database, rename file, give the full path of the original file, and then the full path of the new file. Database altered. Now we can bring our table space back online. Alter table space, users online. And the last thing I'd like to show you here is how you can query your data dictionary. You'll look at DBA table spaces to see information about your table spaces. So here we have our block size. See, this one is a 16K1, and here's the 2K1, whether it's online or offline. For the contents, it will either show up as permanent, temporary, or undo. Whether or not we have logging, notice how your temp table space is automatically set to no logging, because remember, temp table spaces is just used for secondary sorting on disk. There would be no purpose of creating redo information on that. The extent management will either be local or dictionary. Good, everything's showing up as local, that's what we want to see. And the allocation type will either be system or uniform. For performance sake, Oracle automatically makes our temp table spaces be uniformly allocated. And then last but not least, whether or not it's a big file table space. So here's our big TS that we created a few minutes ago. Wrapping up this nugget, we already talked about what exactly is in a table space and why we store it there, as well as assigning table space quotas to limit user objects in certain table spaces. We talked about our locally versus dictionary managed table spaces and the different types of table spaces, such as big files, read-only, regular, undo, and temp. You should now start taking advantage of those temporary table space groups available in 10G and feel pretty comfortable creating, renaming, and dropping our table spaces and viewing information in our data dictionary. I hope this has been informative for you, and I'd like to thank you for viewing.